Hi, my name is Olivia Harper, and these are 5 topics that we have gone over so far that I think will be the most helpful in my future career. The first topic is Design for Manufacturing and Assembly, also known as DFMA. Design for Manufacturing and Assembly is a method of design for ease of manufacturing and assembly of the parts in a product. It is important because it optimizes product design by making it more efficient and cost-effective. Some examples include minimizing fasteners and using a modular design. Minimizing fasteners means that there's less work to put it together and less product being used, and a modular design just overall improves the ease of the manufacturing process. As you can see in the image on the right, on the left-hand side in the conventional design, there are 7 parts and 9 assembly steps. This is not designed for manufacturing and assembly. It requires much more work and materials. And on the right side, you can see that there are only 2 parts and 1 assembly step. This is designing for manufacturing and assembly. Some capabilities of DFMA include that it minimizes waste, enhances efficiency, reduces costs, and improves quality because there's a heavy focus on designing the product in a way so that manufacturing and assembly are as easy as possible. Some limitations include that it requires heavy early integration, heavy initial investment, it's not suitable for all projects, and requires effective coordination between every step of the manufacturing process. The second topic I will be discussing is lean manufacturing. Lean manufacturing is a process that focuses on eliminating waste in manufacturing. It is important because it improves efficiency by getting rid of any unnecessary steps, materials, or processes. In the image on the left, you can see some examples of waste that is found in manufacturing, such as defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Some examples include just-in-time production, Kanban system, and the value stream mapping. Lean manufacturing has several capabilities, including reduced costs, enhanced efficiency, faster production, and environmental benefits. This is because by reducing the amount of product and machinery and human manpower that you're using in the production process, you are spending less money, there's less steps, so your product is able to get made faster, and the environment is receiving a lot less trash and waste from your manufacturing. Some limitations include difficulty in adapting to change, potential for over-optimizing, and a low margin for error. Difficulty in adapting to change is due to the fact that lean systems are often designed for stability and predictability, making it difficult to adapt to rapid changes in the market or customer demand. Overemphasis on cost-cutting and efficiency can also lead to a neglect of quality or customer needs. So this is why over-optimizing can also be a limitation. And finally, lean systems focus on minimizing waste and inventory, which makes the system overall more vulnerable to disruptions in the supply chain or unexpected problems in the production process. The third topic I will be discussing is CIM, or Computer Integrated Manufacturing. CIM is a manufacturing approach that uses computers to control different aspects of production. It is important because it allows for the automation of manufacturing processes and also eliminates a lot of human error. Some examples are industrial robots that you see in the factories, computer-aided process planning, adaptive control, and many more. As you can see in the image on the right, robots are being used to construct the frame of a car. Doing this not only creates a safer environment for the people involved because they don't have to go in there and possibly get hurt with tools or anything, but it also makes it faster and more efficient because the robots are programmed to do that job and they are made to be more efficient in their process of doing it and faster, which means you get more product out and overall make more profit because the robots are able to move faster. Some capabilities of CIM include improved responsiveness, enhanced efficiency, and reduced cost. Responsiveness is improved because with computers and robots, you can simply just send an update to them or make a few adjustments in order to help them continue doing their job. And with humans, you can't do that. It's a much more rigorous process of having them learn how to do it, and they still might not even do it right, depending on what it is. The enhanced efficiency, like I said before, the robots are built for this job and they are made in a way that they are able to perform it seamlessly and fast. Also, once all of the robots or computers are integrated, the cost will go down a lot because they are made to go through several thousands of cycles of manufacturing before they require servicing. Some limitations include that it requires significant expertise, time, and investment. There's a possibility for improper or overly ambitious implementation, and there's a questionable return on investment. The fourth topic I will be discussing is the product lifecycle. The product lifecycle is pretty self-explanatory. There are 5 main stages that a product goes through in its lifetime, and they include product development, market introduction, growth, maturation, and decline. It is important because it helps businesses and manufacturers to make more informed decisions about their product based on where it is in the cycle. Some capabilities of the product lifecycle are strategic planning, marketing strategy, and informed decision making. The product lifecycle is really focused on sales and profits, so it is a big part of, helping manufacturers and businesses make decisions that will help them increase their sales and profit based on where that product currently is in its life cycle. Some limitations include data dependence, imprecise predictions, and it does not account for all external factors. The product lifecycle relies heavily on data about the product and sales and stuff. And the predictions are not always very precise because you can't really expect the market to stay the same forever. And also, it does not account for external factors in the market or the target customers or in manufacturing that could cause complications and mess up plans. The fifth topic I will be discussing is total quality management. Total quality management is a continuous process of finding and eliminating manufacturing errors through every step of production. It is important because it ensures built-in quality by preventing defects from happening rather than detecting them after production. As you can see in the image on the right, some main implementations of this are focusing on the customer, employee involvement, being process-centered, having an integrated system, strategic and systematic approaches, decision-making based on facts, more communication, and continuous improvement. Some capabilities are improve quality because you are getting rid of any errors, increase customer satisfaction because you're refining the manufacturing process and making sure the product fits well within the guidelines of the customer, and informed decision making because you're learning more about the product and any errors and you're able to make better future decisions. Some limitations include that it requires strong leadership commitment because if the leaders aren't doing it, the employees aren't going to follow and enforce it. It is resource intensive because you need to check it at every step of the way and it requires many people, maybe machines, So it just requires a lot of work. And it has a heavy reliance on individual skills because it needs individuals that are able to recognize errors and call them out. Thank you for watching the video of my 5 most important topics, and I hope you enjoyed.